when 0.0129 mole of potassium iodide are dissolved in 10 degrees Celsius water to make 40 grams of solution. Final temperature of the solution is 8.43 degrees Celsius. Assuming the container did not absorb or lose any heat, and the solution has Cp, specific heat, equal to 4.184 joules per gram per degree Celsius, what is the delta H in kilojoules per mole for the reaction potassium iodide dissociate into potassium ion and iodide ion? Alright, so let's take a look at the problem first. What is it talking about? There's a pretty lengthy description here about the process, but let's find out what's really going on. So we dissolved some ionic compound, potassium iodide, and we know, being a soluble salt, when you dissolve that, it's going to dissociate. And you can look at the dissociate process as basically a chemical reaction. Listed it here. And once you dissolve the compound, temperature of the solution actually went down from 10 to 8.43. And temperature went down means solution lost heat. And as we already understand, when things like this happen, to be able to calculate them, we have to take it as an insulated system. That means no heat's out, no heat in. So if something lost heat in the system, it must went somewhere else in the system. Somebody picked it up. So if the solution is losing, who's gaining? There's no other objects. We're not really trying to set out to find the heat capacity of potassium iodide. That doesn't make a whole lot of sense. So who's gaining the missing heat? And when you think about it, the only possibility is, oh, we had a chemical reaction going on here. This chemical reaction must be absorbing heat, and that's why the solution is getting colder. And of course, the reaction here would be endothermic. It's gaining heat, and that means your delta H must be a positive number. So we had a reaction and some solution in there in the insulated system, and now that we clear this up, Q plus delta H, because of the reaction, should equal to 0. Alright, so of course delta H should equal to negative Q. Let's see, how do we do the Q? Well, there's specific heat, so no doubt negative mCp delta T. Mass of the solution, negative 40 grams. Cp 4.184 joules gram degree Celsius. Delta T 8.43, final temperature minus 10.00 initial temperature. Cancel, cancel, cancel. Joules left. Negative here. Well, this is a negative number, so we get a positive value, which is what we want. 263 joules. That's how much heat this particular part of the reaction is absorbing. Is this what we need? Look at the unit. We want to find out how much heat on 1 mole per mole of potassium iodide dissolved it can absorb. This is not 1 mole. This is 0.0129 mole. Well, how do I get that? Simple. You have joules, you have moles. Let's get joules per mole. 0.0129 mole. This will give us, keep this reach suffix, 2.04 times 10 to the fourth power joules per mole. And whenever that's not the unit that we want kilojoules, so we arrange it 20.4 kilojoules per mole. So this means, if based on the data, if I dissolve 1 mole of potassium iodide to make solution, the amount of the heat need to be absorbed from the environment for the dissolution to happen is 20.4 kilojoules.